This lecture will talk about the various trends, technological trends that have led to the Internet of Things, say, revolution. It's an overused word, but let's try to use that right now. So there are lots of different trends that have led to this, led to the incorporation of Internet of Things technology into devices today. And so we'll talk about those things. And it's sort of crept up on us over the years, but now there's this convergence where the situation is right. Everything works, and you can really do a lot of the things that you see in these IoT devices today. So there are several trends. One trend is cost. Is just straight cost of devices. So things have gotten a lot cheaper. Computational technology has gotten a lot cheaper than it used to be. Now, these are extremes, but take ENIAC, early machine, 1945, very early. Not the earliest, but very early machine. At the time, it cost almost $500,000, which in today's dollars is a lot more than that, at the time. So that was expensive, very expensive for the cheapest available machine. Now you can get a laptop for $500. You can get a laptop for cheaper than that. You can get one for more expensive, but you can get a very capable laptop for $500. So things have gotten a lot cheaper over the years. And by the way, I'm saying that you can get a laptop for $500. An IoT device, the computational ability of it is a lot less than a laptop, so it will be a lot cheaper than $500. But the point is that over time, computational technology has gotten a lot cheaper, and so it's within the reach of what you could add on to a lot of different devices. So you wouldn't have wanted to take your standard car in 1945 and add an ENIAC to it because it would add $500,000 worth of cost, right? But now you can add on some low-cost device and get the benefits of computational technology without too much cost. So this is a picture of ENIAC, the original, and it's big and expensive. So this is another thing that's changed. It also has a lot of wires. If you look at it, the way they programmed it was with wires, a lot of wiring going on in there, manual wiring. But so this is a picture of it, and it was big. So that's another trend, hardware size. Things have become smaller. Now that old ENIAC, there was no possible way you were going to be able to get that thing and fit it into a device, into a thing. So that ENIAC was, say, approximately 1,800 square feet, 27 tons. It was a big thing. But a laptop today is small and light. And IoT devices are smaller and lighter than that. So computational technology has also shrunk and gotten lighter to the point that it can be incorporated in lots of different devices. So this is just a size comparison. So we got an ENIAC over there, different lighting, but basically the same machine. And then we've got a laptop. And you can see how the computational technology has just vastly shrunk to the point where you can actually incorporate it into devices. Now, another big trend that makes IoT possible is the fact that computational ability has grown dramatically since, say, 45. So in 45, that ENIAC that you saw, that got approximately 5,000 instructions per second. Now, standard laptop, 18 billion. Now, this is plus and minus, right? But 18 billion, easy. That's a dramatic improvement. And what that gives you is the fact that you can implement a lot more features. There are many things that you couldn't have dreamed of being able to do back in 45 with a computer that you can now handle because you have so many more computations to play with in a unit of time. So for instance, speech to text, right? That's common in phones today, right? Where you talk and it interprets your speech. There's no way with 5,000 instructions per second you could do that in anywhere near real time. Audio processing, network communication, all these things that you can do now, they require lots of computation, and it just wasn't possible with old machines. So with modern machines, there's so much computational ability. Their clock rates are so fast, and there's parallelism, right? These things are multi-core, so you've got multiple processors in one device. There's so much computational ability that you can do so many more things that were thought of back then and couldn't have dreamed of back then. But now we see there's so much you can do. So it makes it more practical to use in devices today to implement the features that we're interested in implementing. Another trend is internet access. So in 45, the internet didn't exist, networking wasn't there, but internet access has improved. So the internet is reachable from a lot of places. First, it exists. Right? It didn't used to exist, but now it's also true that in lots of different places, almost everywhere, you can access the internet through some mechanism. Now, this depends on what country you're in and how much money your country has. Some parts of the world, poorer parts of the world, have less access. We're in the US, you have pretty good access. wherever you want to be. You can access it directly through Wi-Fi. You can access it through jacks in the wall. I mean, we have Ethernet jacks in the wall right here. You can do it wirelessly. You can do it everywhere. Now, different parts of the world have less access. So we can, if you just look at this map, you can see the lighter parts have less access. So most of Africa, a lot of Africa has less access just because they're out of reach of many different, of a lot of the infrastructure that's necessary. But, and you know, there are some places like India is actually lower. In fact, I question this map. I don't think it's as bad as what's being stated on here. But it is generally true that there are parts of the country, poor parts of the world rather, where internet access is harder to find. But generally, it's greatly improved over time. So also the fact that you can do internet access wirelessly. So that actually helps a whole lot because running cables is expensive, where putting up a wireless router is much less expensive. Putting up a cell tower that costs a certain amount of money, but given the expanse that it covers, it's much more cost efficient than having to run wires into everybody's home. So wireless access is one of those things that's ubiquitous now, and it makes IoT technology much more usable and much more possible. Data costs. So the cost of internet access is fairly low. Now this definitely varies depending on where you are. You know, it's never low enough for me, right? I mean, I don't like how much I have to pay every month for my cell phone bill or for my cable bill, stuff like that. But it's low enough that a lot of people can afford it. Now, in poor countries, this is not necessarily the case, but that's changing, right? Bandwidth is high. So what this means is that you can transmit lots of data fast. And that actually enables a lot of different features. So streaming movies, for instance, right? If you want to stream video, you need a lot of bandwidth, right? As opposed to just sending data. If you want to send email, you don't need a lot of bandwidth. Email has a certain amount of text, and it doesn't take much data to send to transmit. But if you want to support video, you need pretty good bandwidth to support it in real time, to send the frames, lots of pixels. It takes you a lot of bandwidth. But bandwidth is available in a lot of places. And wirelessly too. So you can, through Wi-Fi or some other type of wireless technology, cell phones, you can actually get enough bandwidth to be able to see videos through that technology. So the bandwidth actually has enabled a lot of different features in IoT devices. Thank you.